Hi, my name is Randall Barney, Membership Director for the World Teleport Association. We're here at CommunicAsia 2015 speaking with industry leaders about the important issues facing the industry today.
So the satellite industry has seen a tremendous amount of innovation over the last couple of years. If I were to look at a couple that we think are particularly interesting, number one is going to be what's going on with the high throughput satellites. I think we've seen a lot of innovation on the satellite, the spacecraft itself, and what this means is we're seeing a lot more capacity come into the market, and this capacity has a very efficient cost per bit, and so this is driving a tremendous amount of opportunity in the VSAT market space. The other thing that we've seen is that there's been ever greater integration of the components in the VSAT system. A case in point on the part of Hughes, of course, is the Jupiter system on a chip. This is a key component that goes into our new Jupiter ground system. And by the way, just to maybe go a little further afield, the Jupiter system, we're pretty excited about it, and we think that's a big technology innovation in and of itself, and it's not just for high throughput satellites. We've optimized it for high throughput satellites, but it brings a lot of advantages to operators who are operating on conventional satellites. So it's a good example of how the technology innovations for high throughput actually feeds its way through to conventional satellites. Got a couple pretty good examples on the part of Hughes. One example is what we've done with the wideband waveform. This is a Jupiter technology that we developed to really optimize VSAT systems over high throughput, but this is where we can do a forward channel bigger than 200 megasymbols. And the implication of this is by doing a larger forward channel, and by the way, we can also do it all the way up to 32 APSK, we'd get better efficiency, and that drives a lower cost per bit. Plus, because it's a large channel, we're able to give better service because there's just more data available to individual user terminals. That's one example. Another example is what we've done in terms of integration. We're very pleased with our Jupiter system on a chip. This is our ASIC that powers every remote terminal in the Jupiter platform. Because it's a multi-core processor system on a chip, it means that every remote terminal can do 100 megabits of throughput. So we don't really have a consumer terminal or an enterprise terminal. They're all very high power. And that allows operators to address a diverse range of markets. Absolutely. We're particularly excited about DVB-S2X. We think that that's going to improve efficiency, and we're very proud to have been a key contributor to the DVB-S2X effort. Additionally, we think we'll see more advances in return channel technology, in particular higher speeds and the ability to be able to allocate that capacity very efficiently and dynamically. And we think that that speaks to markets such as 4G, LTE, and other kinds of high throughput markets. So at Hughes, we're not standing still. We've got a lot of R&D going on a continuous basis. So you're going to see technology advances come out from Hughes. We're looking at some difficult problems. For instance, LTE traffic, being able to carry it more efficiently over satellite. That's one area we're working on. Another area that's poses challenges is the ever-increasing amount of HTTPS, encrypted HTTP traffic, which is difficult to accelerate. And so we're working on how to best optimize that traffic. But beyond Hughes, we see some interesting things going on with electronic antennas. We think that that has some very interesting applications, particularly for mobility. We'd also like to see some innovation when it comes to having more bandwidth efficiency for video traffic, because obviously we're seeing more and more video traffic in networks in general, and the more we could make this traffic efficient, the better.